Welcome back to another video on Python basics. This is a continuation on simple expressions and operators. So what you see in front of you is the roadmap. Currently, we are on this first block, chapters, if you want to call it that way, and we're slowly moving towards the last block on the far right bottom. And but before we get there's gonna be some foundations to lay so that when we build, we are quite confident that we have a strong foundation, and it's easy to understand some more complex and combinations of what we've learned from the very beginning. So this is just a roadmap just to help you understand where we come from and where we're heading towards. All right, jumping straight to the code. This is my code for today. We'll be looking at assignment expressions, Lambda expressions, as well as your evaluation of expressions. So there are many expressions out there, and they are defined in various ways. So this is by no means the only way of defining them, although but it communicate the message that I would like it to communicate, which is, look, there is such and such a thing out there. If you want to have a look, and this is how it can be used. Not all how it can be used. There are many ways of you can use it because it also depends on your scenario and use case. So starting with the assignment expressions, we're looking at the walrus operator, which is your colon and equal sign, only available since Python 3.8. And for those of you who don't know what that means, it means there are many versions of Pythons, and some version will have some bonuses or some fixes, as you can see here. There are bug fix, security fixes, and all of that. So, and there is no version 3.7, although I think you can still get it from somewhere. Sometimes they usually put all the version or something like that, but I don't think this time around you'll see it. So yes, these are versions, they are available. So I'm currently running in version 3.13, and I'm quite happy with that. And there are many other versions that you can download, and end of support is 2029. It tells you, look, by this time, if there's another version, it's best to move up because there will be a lot of fixes and everything has been done to improve the code. And the walrus operator is one of those. So anything below 3.7, sorry, you're in the dark. It doesn't even exist. I don't think it's a safe thing to do. So that is that about Python 3.8. If you're asking yourself why mention that specifically, it's just to give you an idea of what's going on in the world of Python when it comes to versioning. Now, we're looking at the walrus operator, this colon and equal sign. Now, how I found out that this is useful in a case that I'm going to present it. For me, I found it that it kind of help reduce code usage and lines of code. We don't have, and if you're trying to draft a solution, sometimes you want the simplest way to go about writing it. I'm quite aware that nowadays, with AI, things are auto-generated and stuff like that. But the one thing that AI may not be able to give you is understanding of principles. It gives you a result, but something you need to get down to is how and why it's done the way it's done. So, and I'm hoping this video kind of like still brings that out, that it's easy way to do it. Never worry about learning the stuff and just going straight into getting code. It has its place, but it will be great if you already know how it's been done behind the scene, and getting a code generated would not be a problem. So this is a long way of doing that. So here I've created an array. An array is basically a list of items. It can be mixed. How you create a list, you just create open and close square brackets, and you can put any type in it depending on your use case. In this case, I'm trying to use as many as I possibly can just to practice the stuff that we've learned so far. You have your string, and how you add another item on a list, you use a comma. and then you add another one, you use a comma, and then you add another number. So you can have a mix of them. So, and then what I do next is get the length. Length is an inbuilt function, a reusable code that comes packaged into Python that you can just call, similar to print, and many, many more. The list is, I would say, is almost endless. So, at least for most use cases. So, instead of having to rewrite the whole thing yourself, just call it because it's available. And it's proven that it's been used so many times that it's worth being added to Python as default by default. So length, len for short, and we find the length of the list of items. A length, we just want to know how many items are inside here. In this case, 3. So we print it and we check if is a condition, like your normal if only, yes, that's the one. If n is greater than 2, in which case it is, then print the value of that. That's what we're supposed to see. So if you run that code, we see that we have the value of 3 that's printed, and you also have the list is too long, 3 elements that's printed right after it. So that is the way we can do that. Now, with the walrus operator, we can simplify things from 4 or 5 lines of code to just 2. So let's just identify the blocks here. So we have our if n, which is basically what we had here. If n is greater than 2, but you can see that n now is in this square bracket and 2 is so we still have our section greater than 2. It's just n is now, instead of having to do all of this, it's packaged into this open and close bracket. And what's happening is we're using the valve operator to say, once you get the length of this value, assign it to n, and then outside, if the value of this is greater than 2, then print that in one line, just like that, because of the valves operator. So you're saving those lines of code. That's basically what I could pick up from using walrus operator. Maybe if you know of something of some other use cases, practice, see. Or just research a little bit and find out what's available, what can be used. So that's the one case when it comes to assignment expressions. Now we have the lambda expression. This one is another case of long ways versus short ways of doing things. Lambda expressions, it helps to create anonymous functions. So this is the long way. And remember, length, like I said, len, is a function that is embedded within the Python. So, and you can see I openly expressly of how do you call it? Openly use length, just to show, to see maybe if it can be used or can it be broken? Will it break or something? But ideally, I wouldn't want to use something that Python is already using behind the scene, just so things don't get a little bit messy. So I'm just gonna call it function one, function function one, and function one. So, and we're just gonna leave the whole length out, because if you do that, open close bracket, and you hover over it, you can see it also is a function definition. It returns items. So I'm just trying to avoid in a scenario where I'm thinking I'm getting something and I'm getting something else. Perhaps maybe in this Python version you can use that without a problem, but I'm quite familiar. I just prefer not using anything that's a reserve word, at least the ones that I know. So here's a long way. We define a function, we give it a name like you've seen, and we say, well, we put a placeholder that there is a number, something, a string, or whatever is coming through this. I don't know what it is. I can define it and say, well, it's going to be an integer, but I'm not going to do that. I'm just going to leave it to be any. So how I know it? Because if I hover over that, it says that x is any. So it can be a string, can be integer, it can be a float, any. And then whatever that value is, I want you to add 1 to that value and then return the result. That's what this is doing. And a function will not run unless you call it. Similar to when we are calling a length, These functions exist behind the scene, but you see, in order to use them, you have to call them. And how you call them is basically doing this. And if it returns a value, you can then assign a value to it. If there's no return value, it will not return the value. So you basically need to make sure that you return the value if you wanted to return a value by adding the word return, which is something we're going to look further down as we go through our next chapters. Now, once I run function, I call function and I pass a value, that value is automatically assigned when the function is called to x, and x does the processing, and what we should expect is a value of 5. So if I run that print, I get a value of 5, which is what you see. Variables, you already know what they are, and that looks like a bit too long to me. So we're going to switch to Lambda, and Lambda make things a bit shorter. Now, how does it work? I have a Lambda that's a keyword. So remember, Lambda, we say this, we're creating an anonymous function. So we're not creating a name. There's no function name or something. And we can basically reuse it as we want and then process the evaluation and the result for different use cases throughout the code as Python runs from top to bottom. And so we create Lambda and we say, hey, give us a placeholder like we've done here, X, a placeholder, and semicolon, a colon. And then we say, whatever the value of X is, add 1. And it automatically return the value to the variables add 1, which is what we used to do here. But here we're not putting return. You don't have to do return. You don't have to do that. Oh, don't generate any code. So you don't have to do that. So what it means now is that you can call this and basically pass the value, because Lambda say, hey, if whenever you call this, I'm expecting a value. So that's what's happening here. We're putting add 5 here, and it references and does pass a value and does the processing and return a result, and we get the result that we've assigned to the variable, and we print it out. So if I run that again, I get 6 because 5 plus 1 is equal to 6. How simple that is. So that is what the Lambda does. It's just, I guess, in these two example, what something we can kind of like keep in mind is the simplification in terms of the lines of code. Of course, there are many other use cases where this is useful. I'm just highlighting one of them by also shining some light in some of this stuff so that you can explore more if need be. So that is all for the Lambda expression. Now the last one for today's video is your evaluations of expressions. Now, the previous videos I was explaining this, but I didn't go in depth. I thought, well, let's just add this, and it's good that we're covering this now. Because when you run this, look at what the results are. We get a 20. And the way to get a 20 here is by multiplying 5 by 2 first. That gives you 10. And then adding the 10. And then we get a 20. Now, evaluation of expression, when you're giving Python a code like this, Python based the operation or the evaluation is based on the operator precedence and associativity rules, something that Python does behind the scene. And then to control that behavior, you have to use parentheses. And to get the same different result altogether, I can just add parentheses, and now I'm going to get a different value, which is basically 30. Why? Because Python sees, oh, well, we have parentheses now, so I have to forget about my operator precedence and use what the parenthesis is. So it runs whatever is within the parenthesis first, and then everything outside follows after. So if you have parentheses inside parentheses, like this, it's gonna run what's inside the parentheses first, of inside the parentheses, and then move up that way. I don't know if it makes sense. So we have a 5 plus 1 that gives you 6. 6 plus 10, that's 16. 16 times 2 is 32. That's how you end up with a 32. So it's from parentheses from within, outside. So those are the kind of what I wanted to cover on today's video when it comes to evaluations of expressions, lambda expressions, and assignment expressions. I hope you've learned something new. And until next time, keep well. Bye bye.